the handle, different type of ammunition. These are the grooves of the muzzle. As I said to you before, these are the furrow inside of the barrel, and they give rotational movement of the bullet and makes its flying more stable and longer. By caliber, they are divided into three subgroups: small caliber up to 5 and 6 millimeters, medium caliber up to 7 and 9 millimeters, and large caliber more than 10 millimeters. What does it mean, caliber? Caliber is diameter of the projectile, which is consistent with the distance between the field of two furrows, two contrary furrows, from here up to here. This is the caliber of the muzzle. This distance is consistent with the diameter of the projectile. When I talk about the hunting weapon, we have something different in our mind, and it means the number of the pellets which can be prepared from 1 pound lead. This is the number of the hunting weapon. There is a difference between the caliber when we're talking about the combat weapon and hunting weapon. The smaller the number, the bigger the caliber when they're talking about the hunting weapon. On capsule placement, in what places pose capsule detonator? With central ignition, most of the cartridges nowadays, circular or peripheral ignition, and side ignition. The cartridge consists of three components: capsule or percussion detonator, which is located on the bottom of the cartridge; shell, this is the main part of the cartridge; and projectile, which is located or which is put in the neck of the shell, in the upper part of the shell. The cartridges are combat, blank, or with special purpose, flammable and tracing. This is the construction of the cartridge. Here on the bottom is posed or is placed capsule detonator. This is the gunpowder from the shell, inside the shell. And the upper part of the shell, or above the gunpowder, is posed the bullet itself. Here, this is a hunting cartridge. It's almost the same, but almost, because we have capsule detonator, we have more gunpowder. Now we have some cap. The appointment of this cap or cupboard is just to separate the gunpowder from the pellets, multiple pellets. We said before that the caliber of the hunting cartridge is the number of the pellets which could be produced by 1 pound lead. Here we see a number of pellets in comparison with the combat cartridge, in which we have only one bullet. Now in the hunting cartridges we have multiple pellets. Color or blank cartridges have no metallic bullet. This is a mistake. Bullet or projectile no design, but with pressed cardboard. This is the pressed cardboard, plastic or from cardboard or made some other materials. The capsule detonator is attached to the bottom, as I said before. This capsule contains an incendiary substance. The appointment of this substance is to ignite the gunpowder. In the beginning, the ignition of the gunpowder was done with fulminate, and which is replaced by cyanoxide and some other materials, but it's not so important. The shell, I said before, is a metal cup in which is put gunpowder and projectile. The projectile itself is placed in the neck or in the upper part of the shell. And they are made by different material, they have different mass, depends on the purpose of the weapon. The projectiles are wrapped, they're covered, half encircled, and without shell. This is the construction of the projectile. Different type of bullets, tandem bullets, which have lead and plastic put in each other, and they cause two independent injuries, independent wounds from one shot. Rubber, plastic shot bullets, they are used by the police when there are some riots on the streets, and just to spread out the protesters, they use, in some cases, these rubber plastic shot bullets. Maybe the colleagues from Greece know very well. A couple of years ago, because of the riot, one students were shot, I think in Athens. Sotiris, am I right? Sotiris?
Yes, Professor.
Do you know about this case? 3 or 4 years or 5, maybe 5 years ago, one student was shot in the riot on the street in Athens.
No.
You don't know. You don't know. A couple of years ago, there was a case in Athens. He was shot by the police.
Yeah, now I remember something. Yes.
You remember, I know, you remember.
Yes. There was one case.
The hunting weapons, they use pellets prepared both at the factory or by hand. The size is different, depends on the animals which is pointed to. From 1.25 to 5.5 millimeter. The gun charge is placed in the cartridges. It can be a smokeless, model, or smoke gun. The gun is a thermodynamically stable explosive, which under influence of external influence undergo a rapid chemical conversion with the release of gases. The appointment of these gases is just to give movement of the bullet inside the muzzle. Which are the shooting and damaging factors? The shot consists of ejecting the projectile from the barrel of the weapon under the influence of the gases formed by the burning of the gunpowder. When the gunpowder is blasted, it gives you high pressure inside the cartridge, and it will give the movement of the projectile, and the projectile starts to move itself through the muzzle. When the trigger is pressed, you can see here, the striker's cords strike the detonator, capsule detonator, it ignites and initiates the ignition of the gunpowder. High pressure develops inside, but because of the high temperature, up to 3,500 degrees Celsius. Under this pressure, the project moves along the barrel. This is the mechanism of the firearm injuries. You see how the energy is spread out, 35% to give initial impulse of the projectile, 15 to 20% to overcome the friction with the barrel, and then 40% just to give the projectile ability to move through the air and to reach the target. What is the action of the projectile? There are 3 types of actions. The first type of action is mechanical. Mechanical action is expressed by contusive tearing and drilling action of the soft tissues. Depends on the distance of the shot and the strength of the weapon. Thermal action. We said before that the temperature is up to 3,500 degrees. That's why it's more than obvious that the projectile will have the thermal action. The chemical action is a result of the incomplete combustion of the gunpowder. When I have incomplete combustion of some materials, it produces a carbon oxide. When this carbon oxide, this gas is connected with the hemoglobin, it will give you carboxyhemoglobin. That means that the color of the tissues will be reddish. That's why we say that the projectile have three types of actions: mechanical, thermal, and chemical action. Which are the factors over which the injuries depends on? Type, caliber of the weapon, and charge characteristic, the distance of the shots, the presence of some media or barrier between the weapon and the body. Properties, anatomic, biological properties of the body itself, structure, density, elasticity, presence of the liquid or semi-liquid materials. The design action is the projectile action is most important of all elements of the shot. Depending on the kinetic energy of the projectile, the action is explosive. Explosive action is when we have several hundred kilograms concentrated in one comparatively small area. If this action is over the head, the skull will be blasted or crushed. In other areas, it leads to some tearing or crushes. Drilling, several tens of kilograms. The project pierces the body by killing a portion of skin, enters a puncture wound, and the exit tears. The wedge kinetic energy is equal to a few kilograms. The impact, and if it's the end of the flight of the projectile, in this place, the projectile is lost almost all its kinetic energy and acts only as a blunt object. The action of the projectile is determined by direct and immediate action of the front part. In the place where it enters, huge kinetic energy is concentrated on the comparatively small area. What comes out from the muzzle? Not only the bullet, it's obvious, and something else. These are called additional factors. They are like a cone spread out in the same direction with the movement of the bullet, like a cone. The top of the cone is turned to the muzzle, and the base is turned and is coincide with the movement in the direction of the movement of the bullet. The longer is the distance, the wider is this cone. These are soot, some small particles and burnt particles left from the gunpowder, metallic particles, lubricants. You can see here in this scheme. Changes which are produced by the effect left by the projectile can be divided into three areas. The first zone is zone of immediate wound canal. The tissues are destroyed by the bullet itself. We have nothing in this canal. It's empty space. Its shape and size depend on the feature of the projectile and no tissues. The next zone surrounding this zone of wound canal is called zone of contusion, directly to the primary fire canal, 1.3 to 1.2 centimeters. In this zone, the tissues are severely damaged. They're going to be necrotic from the shock wave. The next, or the third area, is the area of tissue concussion. It zone reaches 4 to 5 centimeters and occurs with the hyperemia, stasis, hemorrhage, and tissue dystrophy. There is a full recovery of this zone in comparison with the zone of the canal and contusion. In the first two zones, there is no recovery. There is full recovery only in the third area of tissue concussion. These two zones are without recovery because the tissues are under the necrosis. How the bullet is acting over the body. The skin is folded inside, and due to a rotational movement of the bullet, the skin is abraded, not only folded inside, but abraded. That's why we will see some specific features of the entrance wound. In the forensic medical practice, we distinguish three distances: shot of support, or close contact, or contact injury, close range point blank shot. In these cases, the gun's muzzle is in contact with the skin. The gun's muzzle is supported. It's going to be full contact or resilient, incomplete contact. A shot from a close distance, when there is a distance between the muzzle and the skin. In this case, when we have close distance, we have action not only of the projectile, but all the additional factors. And shot from a distance only, the bullet is acting. We have no additional factors. Do you understand? The first type is close contact, when there is a close contact between the muzzle and skin. Close distance, when we have action of the bullet and additional factors. And shot from a long distance, in which we have only action of the bullet, not additional factors. Fire injuries can be perforating when the bullet passes through the body. In this case, we have entrance wound, canal, and exit wound. Blind, when I have only entrance wound and canal, and the projectile is inside the body. And tangential, when there is a tangential movement of the bullet towards the body, the bullet simply touches the body. Shotgun contact wound, point blank shot. The characteristics of the entry wound in the shot from a stand or point blank injury are determined mainly by the mechanical action of the gases. In these cases, the wound canal is continuation of the canal of the muzzle or the barrel of the muzzle. All these additional factors are inside the wound, inside the canal. In these cases, the entrance wound is bigger rather than the entrance wound because of the action of the gases. The gases is literally dig up the subcutaneous tissues, and they lift up the skin. This is from one side, lifting up of the skin. From the other side is the pressing of the muzzle. In this way, we can have this comparatively clear-cut imprint on the muzzle left on the skin, and this is typical for the point-blank shot, where I have this fingerprint, let's say stamp or print of the muzzle left on the skin. Do you understand why we have this? Because of the action of the gases. The gases lift up the subcutaneous tissues and lift up the skin. This is from below. On the opposite side is the muzzle of the weapon, oppressing the skin. In this way, we receive this figure, which is called Stanzmark or stamp. This is this stamp. This is the muzzle. This is the imprint left by the muzzle. They are different injuries. This wound is entrance wound. In case when the wound is we get it in the scalp, we can shave the hair just to have better presentation of the entrance wound. When somebody has committed suicide, we can find the drops, blood drops, or some tissues left on the hand, which is holding the gun. You can see some different drops left on the hand. In case we have close discharge of the shotgun, not only the projectile, but additional factors of flame, gas, soot products from the burning of the capsule composition, weapon, lubricant, on some unburned powder particles, and metal are acting like additional projectiles, additional factors. These additional factors expand conically, as I said before, in the direction of the project field, and they are acting in the distance 2.5 times the length of the weapon's barrel. It's orientational, of course. Action of the additional factors, gases, they're acting chemically and thermally, and mechanically. The soot, they have mechanical and thermal action. Non-burned powder particles are mechanical and thermal action. Now, this figure is called powder tattoo, this tattoo surrounding the main entrance wound. These are small bruises, small abrasions left by these small particles come out from the muzzle. These unburned metallic particles, they are embedded inside the skin. Some of them, of course, are embedded. The other are left, these small abrasions and bruises. All this picture is called tattoo. Gunpowder tattoo. It is term in Bulgarian, but I think it's the same in different in the Western books. When I have distant range shotgun wound, only a bullet acts on a remote shot. The incoming firearm or the entrance wound is surrounded with minus tissues inside. Why? Because initially the project exerts severe pressure and pushes the skin inwards, like a cone, inside the wound canal, carrying away a pieces of tissue in the direction of motion of the project. When penetrated, the project folds the skin inside and wipes and produces this excoriation like a ring. That's why anytime when I see this typical wound with minus tissues in the middle, surrounded by this ring of abrasion, we can conclude that this is the entrance wound caused by firearm weapon. In some cases, we will have the ring of pollution left by the soot grease, but more often we'll not see this ring of pollution. But always we see this minus tissue in the middle. It's a lack of tissue because the bullet, based on its rotational movement, tears in the central part of the tissues and carry it away inside the canal and abraded because of the rotational movement the edges of the wound. It makes them like a ring, a braided ring. In blind injuries, it's closely monitored. If they are closely monitored, radiographs and subtracts the projects by passing on for ballistic expertise. Anytime we have to take out very carefully projectile, not to damage it, we use gloves and take it out very carefully and give them to the laboratory to perform ballistic expertise. It's a mistake, ricochet. Ricochet. When the bullet inside the body strikes comparatively solid tissues, for example, bone, there are going to be some internal canals because of the ricochet of the projectile. In the course of the passage through the whole organ, stomach, heart, bladder, due to hydrodynamic pressure of the fluid inside, we will have tearing of these organs. When the bullet passes through the parenchymal organ, the result is distal cracks at the entrance and exit of the organ, the capsule of the organ. Due to high viscosity of the brain, the brain completely bursts when the bullet passes through it. Through the lungs, due to elasticity of these organs, the wound and canal are like a split, small split. The most characteristic is the passage through the bones, flattened bones, for example, like the bones of the skull. At the entrance, creates a hole, comparatively small, comparatively clear-cut hole with oval or round-shaped fracture, with a flat rim. And at the exit is conical with the wider diameter of the external part of the bone. This is just because we've discussed a lot that the tissues, including the bones, they are more resistant to the pressure rather than to extension. That's why in the inner part, when external part of the flat bone, on the entrance road, the bullet exerts compression. That's why the external part of the bone is comparatively clear-cut and with smaller diameter. But the opposite side, these parts of the bone, they exert overstretching, and that's why they are bigger rather than the external one. Because the tissues, including the bone, are less resistant to overstretching rather than to compression. In a long distance shot, the exit wounds are usually greater. The shape of the exit wounds is different. They're gonna be circular, starved, choppy. Maybe we can have a ring of wrinkles on the edge if a skin, a belt, a board, and a wall are lying on a hard part. In these cases, it's difficult to figure out which is the entrance wound and which is the exit wound. In some cases, even though experienced pathologists can do mistake, because when the bullet comes out from inside of the body outwards, if there is some solid material at the exit, the bullet can abrade the wound, the margins of the wound, and it will give you the same picture like the entrance wound. In this case, it's very difficult to distinguish which is the entrance wound and which is the entrance wound. Always, we have to perform detailed examination and to look for these solid objects like belt, board, and wall. This is exit wound. Exit wound. This is projectile left in the subcutaneous tissues. This is the flat bones, the same I explained. before. This is comparatively clear-cut hole fracture. This is the entrance. But look at what happened in the opposite lamina. This fracture is craterated fracture. This is external lamina. This is internal lamina. Why we have this picture? Because from this part of the skull, this is the entrance wound. This lamina sustained only the pressure by the bullet. But this lamina sustained not only the pressure, but overstretching. That's why it's craterated. Because we said that the bones are less resistant to overstretching rather than to compression. On the opposite side of the skull is different. We have the opposite picture. Here we have compression, and this lamina is overstretched. It's internal lamina. That's why this hole is smaller in comparison with this hole. This entrance wound. A shot produced by atypical weapons. How and special purpose weapons. Majority of these weapons are they are defective, self-made, and others. They have defective ammunitions. The most characteristic of these injuries are abundant release of unburned gunpowder, and around the entrance wound is large, irregular in shape, with spotting blackened around it. This is specific for atypical weapons. We can see different illustrations about firearm injuries. This is just to illustrate that this is suicide. When I have suicide, it's very important to observe very carefully the hand, which is suspected to hold the gun. Shotgun wounds, they are hunting weapons in which the entrance wound is bigger, severely influenced by the additional factors and close distance. The edges of the wound is festonated, and they are festonated because of the number of pellets in a common. At the very beginning, they are acting like a common bundle, and if we increase the distance, we will see a number of wounds, and each wound is caused by each separate pellet. These injuries more often are without exit, and the canals may be multiple when the pellets burst into the body, because each pellet acts like a separate bullet. You can see here, we have one big wound hole, like a hole in the middle, with festonated margins left by the different pellets. But here we have comparatively close distance because we see this centrally posed wound left by the bundle of the pellets, because we said before that at the very beginning they are acting like one bundle with this festonated wound. Margins, sorry. What are the main questions? If we have the fire injury, what is the direction of the shot? From front or back is fired. Does the canal's direction match with the direction of the shot? In some cases they match, in some cases they are not. What is the distance? Point blank, close, or distant shot? How many shots were produced? If the hit is directly or we have ricochet, what is the sequence of shots if there are more than one? In what sequences are? In some cases, it's very difficult to distinguish the continuity of the sequence of the injuries. What is the caliber of the weapon? We said, how can I distinguish it? It's very easy when I find the bullet itself. We can tell about the caliber. If we will not manage to find it, it's difficult. We can give you all the information to the ballistics to do their expertise. Otherwise, we will not be able to say about the caliber. Only when we find the caliber. What can we have caused hurt, injury, suicide or homicide, vitality of the injury, which is cause of death. Blast injuries. By the term blast or explosion, we understand extremely rapidly released energy resulting from some changes, physical, chemical, or nuclear changes, and subsequent and expansion of the volume of the starting material and products of this material, resulting in high temperature, high pressure, and this high pressure causes destruction and the replacement of the different objects from the environment. Explosives are chemical compounds or mixtures capable of undergoing external influence to extremely rapid chemical conversion. We can distinguish two processes. The process of explosive takes place in two ways. The first way is by combustion, and the second way is by detonation. The difference is in the speed. The burning occurs at a speed of several millimeters, centimeters, and meters per second, and it's influenced by external conditions. Detonation is through a compression mechanism to the so-called shock wave. This shock wave, the speed of the shock wave is thousands of meters per second. That's why they have extremely high destroying force. I have different explosions. They are initiating or primary. These explosions are put inside the capsule detonator, initiating or primary explosions, bruising or crushing, like a trinitro toluene or TNT. Gunpowder is the most common, peroxylene. The gunpowder is this substance which is filled up in the cartridge. Pyrotechnical compositions. The amount of the damage or the extent of the damage from explosion depends on the structure of the projectile itself, the properties, the quality, the amount of the explosive, the location of the explosion, air, land, or water, and the distance from the body. The striking factor of the bloods are wave or detonation, the shock wave, and the debris from the shell or secondary projectile, stones, trees, soil. It significantly influences the distance from the blast to the victim. We distinguish between the following distances. Explosive action, when there is a close contact between the explosive and the skin or the body, in which the body breaks down, completely breaks down. We'll have severe burns, formation of carboxyhemoglobin. If we perform detailed autopsy, we'll find barotrauma in the lungs. We're talking about direct action of the shock wave when we have localization of the damages on the site of the blast. In this case, localization of the damage is on the site of the blast. Near distance, most of the shots and secondary projectile. This illustration of the body affected by the blast. Full destruction of the body amputation of the fingers or the legs, complete destruction of the body, decapitation in some cases. Which are the main questions? What is the type of explosion? What factors of the blasts are damaging factors? Is it possible that all failures are the result of blasts? What is the distance between the body and the blast? Which part of the victim has been turned to the blast? In some cases, when I have full destruction of the body, we have to identify the victims. And additional research of alcohol and some other toxic substances. These are everything devoted to firearm injuries. Okay, we got some questions.
Did you ever experience any so difficult cases that you cannot like find like
Murder.
the explosion, the blast was too
Yeah.
much?
I've seen, this. There is a street which is called James Boucher near here.
Yes.
James Boucher. 20 years ago, I was on my duty when I worked in Department of Forensic Medicine, and there was a blast in the elevator. In the elevator, 4 people were killed in the elevator in the building. Placed on this street, James Boucher. I've seen once in my professional career, 4 people were killed. They were inside the elevator. The elevator was closed. Can you imagine what happened with that pressure? What tremendous high pressure develops in the closed elevator, and the blast was put on the roof of the elevator. When they pushed the button to start the elevator moving up, and the blast ignited, and all these people were killed. Their bodies were completely destroyed.
Yeah.
I've seen this one only once. I lied to you. I've seen one lady, pharmacist, maybe based on the competition, she was killed because somebody else put the blast on the chassis on her car. And when she started the engine, the blast ignited and the car was completely destroyed and the body was completely destroyed as well. I have 2 cases in my professional career. And I was in forensic pathology in the medical university. I've seen this. What is the most important? The most important is to describe the injuries. They are located all over the body. All the body tissues are completely destroyed, and you can find some debris left by the blast. They are embedded in the body. Some artificial pieces left by the blast left the body. In some cases, we can find some materials left by the car. For example, if the blast is put in the car, some small pieces of gravel, of sand, of stones, wooden pieces embedded in the body. The clothes are burnt. These are the findings when we perform an autopsy of the victim sustained blast injury. But when we have injury, we have a victim affected by the firearm, it's very important to figure out what is the entrance route, canal, and exit route. If we have the transitional movement of the projectile through the body. When the body is, in Bulgaria, say blind, it's comparatively easy because we find the bullet embedded inside the body. But when we have piercing, you saw here in this presentation, piercing means entrance route and exit route is very difficult. We have to determine the caliber of the projectile. I said when we find the projectile, I said the body is comparatively easy because the body, the projectile will give information about the caliber of the weapon. But when we have no projectile, we have to observe very carefully the entrance route, because the entrance route, when we measure the entrance route, the central part minus tissue plus the width of this abraded ring. This abraded ring will give you diameter. For example, if the minus tissue is 5 milliliters and the width of the abrasion of the abraded ring is 2 millimeters, it gives you 7 millimeters. This is the caliber of the projectile, respectively of the weapon. Did you understand, Stiris?
Yes.
We have some other question. We have to determine the entrance route, the exit route, and canal. Canal is the connection between entrance route and the exit route.
Yes.
There is nothing inside because it's a full destruction. There is full destruction, and they will not have reparation of this tissue because the bullet distracts the tissue, severely damages the tissue, and will not have full reparation, full restoration of this. That there will be, if the person managed to survive this injury, will have the scar formation of the scar of this canal.
Mm-hmm. Yeah.
Some other questions?
Carolina asked about how can you identify a fake suicide. Some murders can be great knowledge and make it seem real.
How can we identify suicide from the homicide?
Yes, a fake one, yeah. Fake suicide, actually.
Fake suicide. Fake suicide. When somebody else kills somebody else and they put the gun in his hand.
Yes, and yeah, because they have the knowledge to make it.
It's easy. It's easy because if somebody has committed suicide, we find the pieces of brain, for example, a small splashing of blood on the gun, on his hand, on the same hand grasping the pistol, for example. We'll manage to find that after performing DNA analysis, we identify the pieces of tissue pieces left on the gun or on the hand, grasping or holding the weapon. Or some small particle, unburned small particles left by the muzzle of the gun, small unburned particles from the gunpowder embedded in the skin of the hand.
Mm-hmm.
It's comparatively easy, not so difficult. If somebody wants to pretend suicide, somebody else has committed homicide and then put the gun in the hand of the victim, we will not find these small particles left on his hand. We will see only the gun, but not additional factors. If we observe additional factors in the same hand grasping the gun, it's easy to conclude that this is a question of this is an issue of suicide. But if we see only the gun holding without additional factors, how can I conclude this? Somebody else did it. We'll find this additional factor that somebody else has.
Mm-hmm. Okay.
Ask me something else if you want.
Mm-hmm.
If some question arises, you can contact me anytime.
Mm-hmm.
Me or Dr. Tanko as well. Why not?
Yeah, sure. If we have questions, we will let you know, Professor.
Absolutely.
Thank you for your time.
Anytime you can contact me.
Mm-hmm. Mm-hmm.
It is enough. It's enough for the exam.
Mm-hmm. Mm-hmm. Okay.
You have to distinguish 3 types of shot: distant shot, from close range, and contact. Contact tool. Just to distinguish 3 types. What we observe when I have contact tool, what will I observe when I have close range shot, and what we observe when I have distant. In distant, let's make some small resume. To resume, in distant, should we have action only the bullet, we will see this entrance route, in some cases canal and exit wound, or we find the bullet inside. In close contact injury, close contact shot, we observe the action not only of the bullet but additional factor as well. They are located around the entrance route. In point blank injury, we have close contact, complete or incomplete contact between the muzzle of the weapon and the skin. We observe bigger entrance wound in comparison with the exit wound. All the additional factors we can find inside the wound, inside the canal, and we'll see imprint on the gun left on the skin surrounded the entrance wound. I said why? Because we have an action of the gases. They expand the tissues and lift up the skin, and this lifted skin encounter the muzzle, and in this way the muzzle left imprint, clear-cut imprint on the skin. Do you understand?
Mm-hmm. Yes.
Ask me something else if you want. Up to you, Sotiris.
If if the bullet stays inside, someone can die also from inflammation, or
If somebody will die, she or he will be autopsied afterwards, and we'll find the bullet. But of course, in some cases, the person managed to survive.
yes,
If the bullet is in some specific place and there is a danger, in some danger exists. For example, next to the big vessel, next to the big nerve, this bullet creates some danger in the future life of the patient. Of course, they will be operated on, and the surgeons will remove the bullet. Otherwise, some severe bleeding could follow afterwards. But if the bullet is some comparatively not so dangerous zone, some safe place, they will not have any life-threatening troubles for the person in his future life. The bullet will stay inside the body.
okay. Thank you. I don't know if someone else has.
Ask me something if you want. Can ask me something else. I'm at your disposal now.
Mm-hmm.
I don't like lectures. I like conversation.
Yeah.
Conversations.
Me personally, I don't have any questions right now.
If you have questions, Rouse, call me anytime.
Mm-hmm.
You know my office. If you have
Yes.
some special, can I?
Mm-hmm.
Maybe some other questions, not so obligatorily linked to forensic pathology, about the exam, about the term, about the session. You can know where's my office. You can come to my office and we discuss about it anytime when you have free time.
Mm-hmm. Thank you very much, Professor.
You're welcome to this. And the others, of course. Ciao for now.
Bye-bye. Have a nice day. Thank you for your.
Same to you, ladies and gentlemen. Ciao.
Bye-bye.
Bye.